So in grammars, we have two types of normal forms. One is Chomsky normal form, another is Grabbage normal form. The first thing, why do we require normal forms? Basically, if we go on writing production rules in this way, like A gives P, where A is a variable and B is combination of variables and terminals, possibly empty, which is nothing but the definition of production rule for contextual grammar. One may write any type of productions, any length productions, and so on. So for that purpose, we need to normalize them in such a way that generated production should follow some pattern, some specific pattern. For that purpose, we have various normal forms. Out of that, these two normal forms we are going to see today. One is Chomsky normal form, another is a Grabbage normal form. So let's focus on Chomsky normal form first. What does it say? It says that the productions are limited to two non-terminals or single terminal. What does it mean? That any grammar in which the production rule contain either single terminal or two variables, then such a grammar is referred as a grammar in Chomsky normal form. So where this beta belongs to T and A comma B comma C belongs to V or N. If we have all the production rules in this form, we refer such a grammar as a Chomsky normal form grammar. So what is the process for converting any grammar into equivalent Chomsky normal form? The step one is, as usual, that whatever context-free grammar is given to us, we need to convert that context-free grammar into a simplified grammar form. So let's consider this as an example where we have two variables, variable A and variable B, whereas terminal symbols are 0 and 0. So basically 0 is the terminal symbol and A and B are the variables here. Assume that A is our starting variable. Okay. So we can write the production rules for this as V is equals to A comma B, that is tuple. T is equals to 0. P is A gives B, A, B, bar epsilon, and B gives 0, 0, bar epsilon. Okay. And A as a starting variable. A is our starting variable. So we have already seen the steps for simplification of grammar. The first step is what? We need to look for, is there any useless symbol available in the grammar? Here symbols available in the grammar are A and B, wherein A generates epsilon, that means A is not a useless. B also generate epsilon or set of terminals, that means B is also not useless. What does it mean? That the grammar contains no useless symbols. So step one talks about simplify the given grammar. This grammar doesn't contain any useless symbol. So first criteria is satisfied. Second criteria is removal of epsilon productions from the grammar. If you see here, we have A gives epsilon and B also gives epsilon. But since this grammar has A as a starting variable, we can generalize it that this grammar generates possibly an empty string also. So A gives epsilon cannot be removed here. We have B gives epsilon, which variable we can replace. So let's go for it. Removal of B gives epsilon, that we'll see. Now A gives, do we have B available here? Yes, 1, 2, and 3 places we have B. Just replace this epsilon in these places. So what we have? We have AB bar BA bar A bar B bar epsilon. Okay. Similarly, B gives 0, 0. Okay. So this B gives epsilon be removed. But if you see here, we have A gives A. It is but natural. A gives A means we are ultimately talking about starting variable only. So this also needs removal. A gives AB bar BA bar BAB. Here also we need BAB. Okay. Bar B bar epsilon. And B gives 0, 0. This is our resulting grammar after removal of B gives epsilon from the production tools. Now, what is next step? Next step is removal of unit productions from the grammar. When we say removal of unit productions, we need to look for, do we have any unit productions here? If you look at here, A gives B. This is our unit production available. So let's remove that. Remove means what? Ultimately, by removing it, we will replace the B with its production tools. A gives AB bar BA bar BAB bar 0, 0 bar epsilon. Further, B gives 0, 0. So this is equivalent production for the grammar after removal of unit productions. Next, removal of any useless productions from the grammar. We do not have any useless production in the grammar. So this is our equivalent grammar in simplified form. Now this simplified form grammar we need to convert in the equivalent Chomsky normal form grammar, which contains either two non-terminals or single terminal. Let's look for this grammar. Do we have any productions wherein we do not have either two variables or single terminal? Let's check. Here we have two variables. Here we have two variables. Here we have three variables. So this is not in CNN. This is we have two terminals. This is not in CNN. Here epsilon we are considering a single terminal. So this is in the required form. B gives 0, 0. This is not in required form. Okay. So we need to focus on 1, 2, 3. These three productions to convert into its equivalent CNF form. How to go for that? We'll go for the step number 1, where we have non-terminals available and the length of production on the right hand side is more than 1. Such production rules are 1 and 2. Okay, what we will do here, we'll replace them with a dummy variable so that terminals can be converted into variable. So let's use another variable C, which is leading to 0. Ultimately, after this step, what we will do is we will have a production of this type. A gives AB bar BA bar BAB bar CC bar epsilon and B gives CC. So this is the grammar after removing all the productions consisting of more than one length but not containing variables. Okay. Now here, apart from this, we have this as a last variable production. C gives 0. Now here 1, 2, 3, 4, 5, 6. These all are in CNF form except this one. So our next task is to convert this into a production containing two variables only. Okay. So let's go for it. How to do that? Any guesses? A gives AB is already in CNF. BA is already in CNF. We'll say B followed by a dummy variable D1, where D1 is AB, then TC, then epsilon. Remaining productions are there, CC, C gives 0. Now, this resultant grammar contains either two variables or single terminal. So this is an equivalent grammar in CNF form to the original grammar which was given us as a question. Any queries on this? If you have any queries, please let me know. Good. So I have another problem available. We'll see how to check that. This is another grammar which we need to convert into equivalent CNF form. S gives ASA, AB, B, S, B gives B this, right? Now what is step number one? Step number one says removal of useless productions from the grammar, useless symbols from the grammar. Useless means the one which do not results into generation of a terminal. Okay. So yes, we have seen similar example earlier. First step is removal of useless symbols. We do not have any useless symbols available in this grammar. So proceed with the second thing, that is removal of epsilon productions. Epsilon production available here is B gives epsilon. Let's focus on removal of it. S gives ASA bar AB bar A. So we have replaced this B with epsilon here in AB. So we got A epsilon, that is A. Similarly, here A gives this B to be replaced with epsilon. Similarly, this B to be kept for this small b. So B is added followed by S. Next, B gives small b, which leads A gives epsilon as another unit, another epsilon production. So let's remove this. What we did here is remove B gives epsilon. Now we are doing remove A gives epsilon. So ultimately S gives SA bar AS bar ASA bar AB bar A is 1. Then A gives B bar S and B gives B. So this is the equivalent production rules after removal of epsilon productions from the given grammar. Next is removal of unit productions from the grammar. What are unit productions here? The unit productions are A gives B and A gives S. Okay, so let's go for it. S gives SA bar AS bar ASA bar AB bar A. A gives this A gives B to be replaced, so we will have A gives small b. Then A gives S, so replace all symbols. S A S bar ASA bar AB bar A. Okay. Next is B gives small b. Do we have any unit production available here now? No, all unit productions have been removed. Next step is looking for the useless productions. Do we have any useless productions available here? The answer is no, we do not have any useless productions here because S generates A, S generates SA, where S generates A and A generates B. So this is useful, this is useful, this is useful, this is useful. All are useful. So this is our equivalent simplified grammar. Now to this grammar, our now task is to convert it into Chomsky normal form. So this is our step 1, that is simplification of grammar. Step 2 is to look for the production rules which has length more than 1, right? And they do not contain non-terminals, rather they contain terminals. So let's check. These are two variables, three variables. So this is not in CNF. One variable, one terminal, so not in CNF. This is in CNF, 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 not in CNF, not in CNF, 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 and CNF. So 1, 2, 3, 4. These 4 grammar rules we need to convert into equivalent CNF. What we'll do, we'll go for step 2, wherein all the terminals which are associated with variable or any production wherein more than 2 terminals are available, we'll convert them into equivalent variables. So how many such terminal symbols available which are associated with variable? We have this available which is associated with the variable. So let's replace this with a dummy. Let's say CA use A and rewrite the whole thing. SA bar AS bar ASA bar CAB bar A gives B bar SA bar AS bar ASA bar AB bar A. So this AB would get converted to CA again and B gives B. Okay, so let's take again all the production rules for their availability in CNF. This is CNF, this is CNF, this CNF 1, 2, 3, 4, 5, 6, 7. These all are in CNF. Only 1 and 2, these two are not in CNF. Let's go for next step, step 3, wherein we'll use dummy variable, let's say D, in order to convert this into equivalent CNF form. Okay, let's say DA is equals to SA. Let's rewrite the grammar. SA bar AS bar ADA bar CAB bar A gives B bar SA bar AS bar A B A bar C A B bar A, and B gives small b. So this is an equivalent CNF form to the given grammar. If we see here, all the productions are either in the form of containing two variables or single terminal. If any questions, please let me know.